Well, hello again, everyone. This is Mr. Reeves with you for the final grade 8 CAASPP Math Practice Test video. We're up to problem number 28, and we're going to work our way to the end. All right, let's dive in. Samantha gathered the following information on a given day at the dog park. There are 32 dogs playing at the dog park. 15 of the dogs are puppies. 11 of the dogs are not puppies and have long hair. There are 6 more dogs that have long hair than dogs that do not have long hair. Fill in the table completely to represent Samantha's data. All right, so if you look here, we have a table that has rows going across for data and columns going down. You notice the bottom row is totals and the final column is totals. And then we have these cells here. So let's talk about what each of these would represent before we try to fill them in. First of all, this right here, the end of the bottom row and the bottom of the last column, this represents the total of everything. All right, so that's the grand total of, in this case, all of the dogs. All right, so hopefully you're already thinking about what's going to go there. All right, this total right here will be the total of dogs that are not puppies. This total here will be the total for dogs that are puppies. Over here, this total is going to be the total for dogs that have long hair, and this is going to be the total for dogs that do not have long hair. And then these are going to be a combination. So, for example, this cell right here has to be the combination of dogs that have long hair and dogs that are puppies. So this would be long-haired puppies. This one would be long-haired that aren't puppies, right? This one right here would be puppies that don't have long hair, or short-haired puppies. And this one right here, these dogs are not puppies and they don't have long hair. So hopefully that table makes sense to you. If you've ever played the game Battleship where you have like G7 or H4, then it's kind of that same idea, right? You're looking for the combination of the row and the column. So here we go. All right, so let's go back and see what it says. There are 32 dogs playing at the dog park. That statement right there, where are we going to put that in this table? 32 dogs at the dog park. Well, that represents the overall total, right? So that should go right there. So I'm going to go ahead and right there, I'm going to put the number 32 because that's going to represent 32. I think I'm going to put the number 32. There we go. All right. Okay, so what else do we have? It says 15 of the dogs are puppies. So where would we represent the puppies? Just puppies, right here. Well, dogs that are puppies, right? There it says dogs that are puppies. And which dogs do we want that are puppies? We want all the dogs that are puppies. So that's going to go right there. So that is going to be 15 right there. All right, 11 of the dogs are not puppies and have long hair. So notice right here, we have this word and that and is going to connect the not puppies with the long hair. So let's take a look at this table. Where is the not puppies that have long hair? All right, well, here's the not puppies, right? And here is the long hair. So we're looking for the intersection. So that's going to be this box right here. And that number is going to be 11. All right. So we're going to go right here. And now we're going to put in 11. All right. Okay. Looks like we have one more thing we can fill in here. It says there are 6 more dogs that have long hair than dogs that do not have long hair. There are 6 more dogs that have long hair than dogs that do not have long hair. Well, the problem is we don't know how many total dogs have long hair, do we? All right. This box right here will represent the dogs that have long hair. This box right here will represent the dogs that do not have long hair. So we know that this number is going to be 6 bigger than that number. The problem is we don't know either one of these numbers. So you might think we're stuck. But let's see, is there anything else we can fill in here? Well, if we look at the total, we know the total number of dogs is 32, right? There are a total of 32 dogs. And what do we know? We know 15 of those are puppies. So what can we find? We can find the number of dogs that are not puppies, right? We can go ahead now to get that number right there. We could do the 32, which is the total, and we could subtract the 15, which is the puppies. And when we do that, what are we going to get? We're going to get the ones that are not puppies, right? All right, so 12, I'm going to have to borrow here, right? 12 minus 5 is 7. Okay, that's not a 1. That's actually going to be a 2 here, right? That's 1 goes there. And 2 minus 1, that means there are 17 that are not puppies. So now I know that that number right there is 17. Well, hey, then that means I can find this number, right? Because if there are 17 dogs that are not puppies and 11 of them have long hair, then this would represent dogs that are puppies that don't have long hair, right? 11 plus this has to be 17. Just like 15 plus 17 turned out to be 32. All right, well, I hope that you can do this mental math. What plus 11 is 17, or what is 17 take away 11? It is 6. All right, so now I know that that is 6, and that is 11, and that is 32. All right, is there anything else that we can fill in that we know? Let's go back because it looks like maybe that we are stuck here. All right. Samantha knows there are 32 dogs at the dog park. So we've got the 32 dogs at the dog park. That part is right there, right? Okay. 15 of the dogs are puppies. We've got dogs that are puppies. 15 right there. All right. 11 of the dogs are not puppies and have long hair. So these are not puppies and have long hair, and we've got that right there. And we know that there are 6 more dogs that have long hair than dogs that do not have long hair. Now, we haven't used this. All right, now the problem is we don't know either of those. So, maybe we're going to have to actually represent something we don't know like we do in algebra with a variable. So, dogs that do not have long hair. Dogs that do not have long hair, I'm going to call that X. And dogs that do have long hair is 6 more. Well, how do you do 6 more than something? You add 6. So I got stuck with the numbers. I filled in all the numbers I could, but now I can say, okay, what do I know? I know that the total with long hair plus the total without long hair is going to give me the total here. So X plus 6 plus X has to equal 32, right? Well, X and X here, those are like terms. I could put them together and I get 2X plus 6 is 32. I then subtract 6. 2x is equal to 26. I then divide by 2, and what do I get? I get x is equal to 13. So what do I know? I know that this is 13. And if this is 13, and this has to be 6 more than 13, what's this going to be? 13 plus 6 is 19. And what do you get when you add 19 plus 13? You get 32. All right? So the dogs with long hair, right here, this one needs to be 19. The dogs that do not have long hair is 6 less than that. It's 13. All right, and now we just have these two boxes that are left, right? But I know these two have to add up to 15, and that doesn't help me because there's lots of combinations that can add up to 15. Could be 14 and 1, or 7 and 8, or 12 and 3. But if I go across, I know that this box plus this box has to equal 19. Well, how many are in this box? 11. Again, if we do mental math, what do you add to 11 to get 19? You add 8. Or 19 take away 11 is 8. And now I know, oh, this plus this has to equal 15. But once I know that is 8, I know that is 7. And what would a good math student do? He or she would check his or her work. And if I go across 7 plus 6, does that equal 13? Yes, it does. So if we check it going down, 8 plus 7 is 15, 11 plus 6 is 17, 19 plus 13 is 32. All of the columns work. And going across, 15 plus 17 is 32, 7 plus 6 is 13, 8 plus 11 is 19. So we have all of the boxes filled in. It satisfies all the information Samantha gave us and fills in all the information that she didn't give us. Awesome. All right, let's go on to question number 29. All right, enter the y-coordinate of the solution to this system of equations. All right, okay, systems of equations. We previously, not too long ago, solved a system of equations by graphing, and we graphed the lines and we found where they intersected. So one option would be to get out a piece of graph paper and graph this line and graph this line and see where they intersected. Because what are we looking for? We're looking for the value of x and the value of y that makes which equation true? We want to make both equations true. So there are many, many combinations of x and y that will make negative 2x plus 3y equal negative 6. And there are many, many combinations of x and y that will make 5x minus 6y equal 15. But there's only going to be one. There's only going to be one single value of x and y that is going to make both of these equations true. So again, there's three ways that you should have learned to solve systems of equations. The first is by graphing and finding the point of intersection. The second is by substitution. And substitution is when you solve one of the equations for either x or y, and then you plug that into the second one. And the third way is by elimination. Now, sometimes elimination we call the addition or subtraction method with multiplication. All right, so any of these ways could work. They all will give you the same solution. Well, they didn't give us a graph to work with, so I'm not going to go ahead and use graphing this time. When looking at these equations, there's not one that looks like it's easily solved from one variable to the other, so I'm not going to use substitution. Elimination is the way I'm going to go. And my favorite method with elimination is addition. So what I would like to do is add these two equations together in such a way that either the x variable or the y variable is eliminated. Now, just a reminder, how do we eliminate things by adding? Well, if I add 2 plus negative 2, what do I get? I get 0. Or if I add negative 7 plus positive 7, what do I get? I get 0. And why does that happen? Because adding opposites results in a sum of 0. Every time. Adding opposites results in a sum of 0. So I want to look here and say, can I create a pair of opposites? Well, what's the coefficient in front of the x? It's negative 2. What's the coefficient in front of the second x. I'm sorry. The coefficient in front of the first x is -2. The coefficient in front of the next x is 5. If I add -2 to 5, do I get 0? No. They are not opposites. Let's take a look right here at this one. What's the coefficient in front of the first y? It's 3. What's the coefficient in front of the second y? It's -6. If I add those together, will I get 0? No. So, but we have learned that you can actually then use multiplication if you don't actually have opposites to create opposites. Now, does 2 go into 5 evenly? The answer to that is no. Does 3 go into 6 evenly? The answer to that is yes. If I take this top equation and I multiply this top equation by 2, then I am going to get this 3 to become a 6. So I'm going to go ahead and do that, and that top equation is going to become -4x plus 6y equals -12. And just a reminder, if you did not remember, multiplying a linear equation by a constant does not change any of the solutions. So if I were to graph this line and I were to graph that line, the graph would look exactly the same because it has all the same solutions. So even though the equation is different, the solutions are the same because I doubled the coefficient in front of the x, I doubled the coefficient in front of the y, and I doubled the constant here at the end. All right, the second one I'm going to keep the same. The second equation is 5x minus 6y equals 15. But now take a look at what we have. What's the coefficient in front of the first y? The coefficient in front of the first y is a positive 6. The second coefficient the coefficient in front of the second y is -6. And what do I now have? I now have a pair of opposites. And so if I add these two equations together, -4x plus 5x is going to give me 1x. These are going to be eliminated. That's why we did it. So x equals, how nice is that? 15 plus -12 is 3. And just a reminder, when you add equations together, if you get a solution that works for them added together, that solution is also a solution to either of these. So adding them together, we found out that x equals 3. But remember, we're not just looking for x. We are looking for an x and a y that makes both equations true. Well, we now know 3 is the value of x that will make both equations true. Now we need to find y. So how do you find y? Well, it'd be nice if we had an equation that said y equals, and then we could just plug in the x and get it. We don't have one that says that, but we have this equation here, we have this equation here, and then we have the one we created. So we actually have 3 equations we could work with that tell us how x and y are related. All right, so I like to use one of my original equations whenever possible. So I'm going to go ahead and go back to that equation right there. So -2x plus 3y equals -6. Again, there are many x's and y's that will make that true. But what do we know? We want to find the y that makes this equation true when x is 3. So I'm going to go -2 times 3 plus 3y equals -6. So I substituted 3 for x. And now I have an equation that only has y. That gives me -6 plus 3y equals -6. I hope right now you're already seeing what y is going to be. But if not, I will add 6 to both sides. Those cancel and those cancel. And I get 3y equals 0. And when I divide by 3, I get y equals 0. So 3, 0 is the value of x and y that make both equations true. And when we did that system problem earlier where we solved by graphing, I said one of the great things is we can always check our answers. Well, we can do that right here. Again, we just did it for this one, right? If we do negative 2 times 3, we get negative 6. 3 times 0 would be 0. And negative 6 plus 0 equals negative 6. So we just showed that it makes this first equation true. But how about this one right here? Let's try it. 5 times 3 minus 6 times 0 is supposed to equal 15. Well, what's 5 times 3? 15. What's 6 times 0? 0. Does 15 minus 0 equal 15? It does. And so what did we just show? We just showed that the point 30 is the ordered pair, the x and the y value that make both of these equations true. But if you read the question, it just asks you for the y coordinate. All it wants is the y. X was 3. What was y? Y was 0. So right here, all we have to do is put 0 and then go on to question number 30. All right, we're almost done. Can you see the light at the end of the tunnel? All right, the ratios A to B and B to C are equivalent to one another. Select all the statements that must be true. All right, A to B and B to C are equivalent. Again, this word equivalent means that they are equal, but they look different. They are equal, but they look different. So when they tell you two things are equivalent, you can actually set them equal. And these are ratios, and you can write ratios with colons like they did, or you can write ratios as fractions. So A over B has to equal B over C. A over B has to equal B over C. All right, now we're going to select all of these statements that must be true. All of these statements that must be true. Now, I remember doing problems like these, and I always hated problems like these because I'm like, well, how am I supposed to know? I have no idea what A and B and C are, all right? So sometimes it helps if you actually find values that make it true. All right, so let's see if we can come up with one that will make this true. So how about if we do 1 over 2? 1/2, right? So if in that case, A would be 1 and B would be 2. So what would this one have to be right here? This one would have to be 2. And let me ask you then, okay, what would go here? 1/2 is equal to what? 2 over 4, right? All right, let's try another one. How about if we did 2 over 3? 2 over 3. Well, what would have to go here? This would have to be 3. No, let's not do that one because that's going to be kind of hard. Let's do one that will go into. How about 2 over 8? Let's do that one, okay? 2 over 8 equals 8 over, All right, well, 2 over 8, that simplifies to 1/4. That one's times 4, and 8 times 4 is 32. So there's another example. All right, so we could come up with a lot of ones, but it helps sometimes if you have some numbers, and then we can look. Now, just because it makes it true for one doesn't make it true for all, but if we can make it false, if it doesn't work for one, then we're good, right? Because in order for something to be true, it must be always true. So when something is true, it must be always true. But if something is false, do you know what that means? It has to be false at least once. So if we can show that it's false for our numerical examples, then we know the answer can be false, right? If we show it's true for our numerical examples, that may or may not always be true. But let's see if we can work this out, all right? So A is equal to C. All right, so here's A, right? And here's C. We'll take a look at our example right here. Does 1 equal 4? Nope. Does 2 equal 32? Nope. So in both of our examples, it was false, although we only had to see that it was false once. So this one is equal to no. All right, or it is not true. Does B over A equal C over B? If I flip these over, let's take a look. Okay, let's take this one and flip it over. What do we get when we flip 1 over 2 over? We get 2 over 1. And what do we get when we flip this over? We get 4 over 2. Well, what's 2 over 1 equal? 2. What's 4 over 2 equal? 2. So it worked for this one. Let's try this one. 8 over 2 equals 32 over 8. Well, what's 8 divided by 2? It's 4. What's 32 divided by 8? It's 4. So it worked for both of these. That doesn't prove it always works, but I want you to think about it. All right? If the top divided by the bottom equals the top divided by the bottom, doesn't it make sense that when you flip it over, right? The bottom divided by the top would equal the bottom divided by the top. If you think it through, I think you'll see that it does make sense. So this one is going to be yes. All right. All right. B minus A equals C minus B. All right. So again, if we take a look at our example, I'm going to go ahead and go over here. For our example right here, what did we have? We had that A was equal to 1, we had B was equal to 2, and we had C was equal to 4. All right, so let's try this. B minus A. B minus A is going to be 2 minus 1 equals C minus B. C minus B, 4 minus 2 is equal to what? 2 minus 1 is 1. 4 minus 2 is what? 2. Does 1 equal 2? The answer is no. And again, in order for something to be false, it only has to be false at least once. And we just proved it didn't work for this one. So therefore, we can say that that one is false. A is less than B, and B is less than C. A is less than B, and B is less than C. So for this example, for the one we have here, 1 is less than 2, and 2 is less than 4. So it is true for this one. How about this one? For the second example, what did we have for A? We had, over here though, right? We had A was 2, and B was 8, and C was 32. Does it work for that one? A is less than B, and B is less than C. So it worked for that one as well, right? So maybe you're thinking, oh, that looks like it's true. All right, it worked for this one. It worked for this one. But let me remind you, when we flipped it over, was it still true? Do you remember when we flipped this one over, we got that? So for this one right here, what is A? A is 2. And what is B? Oh, wait, it wasn't the same. I apologize. No. Because when we flipped it over, these two weren't the same anymore, were they? These two were now different. So we can't actually use that example. All right. So let's try one more, and let's see if we can do one more example. So what about if we have 3 over 9 equals 9 over, 3 over 9 equals 9 over 27, because that's times 3, right? A is less than B, and B is less than C. Could we come up with one where it was bigger? What about if I did 9 over 3 equals 3 over, well, 9 over 3 is 3, so this would have to be 1. Does that work? 9 over 3 equals 3 over 1? Is that true? What's 9 divided by 3? It's 3. So this one works, doesn't it? All right, it makes this true. A over B equals B over C, but A is not less than B, and B is not less than C. So this one is a No. All right, last one. If A equals B, then B equals C. If A equals B, then B equals C. So we can't use our examples that we came up with. So last one. If A equals B, let's just say that A is 4, then B would have to be 4, right? So that would mean B is 4, and then C would have to be 4. They would all have to be the same, right? So if A equals B, then B has to equal C. They'd all have to be the same. So this one is also going to be a yes. So sorry about that. I got a little more bogged down in that one than I needed to, but I hope you understand the idea that sometimes using numbers will make it easier. And again, you can prove something's false with numbers. You can't prove it's true with numbers, but it can help you reason your way through and maybe convince you that it is true all of the time. So we're looking for the second one and the last one as being true, and the first one and the third one and the fourth one as not being true. All right, 31. Okay. Thinking this one's going to be a little easier than that last one. A cone with a radius of 6 feet and a height of 15 feet is shown. Enter the volume in cubic feet of the cone. Round your answer to the nearest hundredth. All right, so I believe in the previous video we did a cylinder, and now we're doing a cone. So again, in the previous video we said that the volume of a cylinder could be found by doing the area of the base times the height. And we said that the area of the base was a circle, right? And so that turned out to be pi r squared. And then we did the height, which was the height. So if this were a cylinder, the volume would be pi r squared h. But a cone is actually smaller than a cylinder with the same base and the same height. In fact, if I were to go straight up, I'll do my best, and I were to go straight up here. Again, this is a sketch. Please forgive my sketch. But if I were to go ahead and try to draw a cylinder that had the same base and the same height, right? The height is 15 feet. Hopefully you can see that the cone is smaller than the cylinder. The cone fits into the cylinder, right? And then the question is, how much smaller is it? Well, hopefully you remember from when you were studying this that it is actually 3 times smaller, or it is 1/3 of the volume, or you could fit 3 of these cones into that cylinder. So what we usually do is right here we put 1/3 in front, or sometimes we say it's that volume of the cylinder divided by 3. All right, so pi r squared h divided by 3, or 1/3 times pi r squared h. All right, so here we go. So let's go ahead and fill that in right here. Pi, of course, is equal to pi. The radius they gave us right there is the radius. The radius is 6 times 6 squared. And the height in this case is 15. But then we're going to divide that by 3. All right, now hopefully you remember that when you have a fraction and you have a number in the denominator that is a factor of the number in the numerator, you can divide. So I'm going to go ahead and divide here before I go to the calculator. 3 goes into 3 1 time, 3 goes into 15 5 times. So what I actually want to do in my calculator is 5 times pi times 6 squared. Or because this is multiplication, I can actually do this in any order I want to because of the commutative property. So 5 times pi times 6 squared. You might even mentally say, well, I know what 6 squared is. 6 squared is 36. So 5 times pi times 36. And that will give us our volume. So here we go on our calculator. 5 times pi times 36, or if you wanted to know how to do 6 squared, I'll show you. You could do 6 and then the squared button. There you go. 5 times pi times 6 squared. And we get 565.48667776. But what did it ask us to do? It asked us to round to the nearest hundredth, right? So that means we're only going to go 2 places, and when we go 1 place more, we see that that's a 6, which means we need to round up. So what are we looking for? 565.49. 565.49. And again, that would be cubic feet. But as I've said many times throughout these videos, if they give you the units in the question, you do not need to put the units in the answer. So 565.49 cubic feet is the volume of this cone, which is 1/3 the volume of the cylinder with the same base and the same height. And we are on our last question for this practice test. Here we go. There are a total of 500 students in grades 1 through 5 in an elementary school. 17% of the total are in first grade. 19% of the total are in fourth grade. The number of third grade students is 9 less than the number of fourth grade students, and the number of second grade students is 10 less than the number of fifth grade students. All right, so hopefully this reminds you a little bit of that puppy dog problem we did earlier, except instead of having 2 rows and 2 columns, we just have this one column that we have to fill in, but we have first, second, third, fourth, and fifth to work with. All right, so let's take a look at what they gave us. There are a total of 500 students. Now, they did not give us a total row here, so I'm going to go ahead and write it in. So first, second, third, fourth, and fifth all added together is going to give us the total. And we know that that total is 500. Okay, we don't know how many are in first or second or third or fourth or fifth, but we know that the total is 500. What else did they tell us? 17% are in first grade. So this is 17% of the total. And 19% are in fourth grade. All right, so first grade is going to be 17% of what? 500. And fourth grade, down here, fourth grade is going to be 19% of 500. So what do I know? I know that there's a few more fourth graders than there are first graders. 2% difference. So how do I find 17% of 500? I need to do 0.17 times 500. And how am I going to find 19% of 500? 0.19 times 500. All right, let's do that then. Once again, they're letting us use a calculator, which is awesome. 0.17, 17% of 500 gives me 85. 85. So right now, I'm going to go ahead to my first graders, and I'm going to go ahead and type in the 85 because I can lock that in because I know that's correct. All right, and now for fourth graders, I'm going to go ahead and clear all that out, and I'm going to do 0.19, 19 times 500, and that gives me 95. So it actually wasn't a few more, it was actually 10 more fourth graders than first graders, right? By the way, that tells me that 2%, what did we just find out? We just found out that 2% of 500 is 10, right? Because the difference between these, fourth grade, this again was 17%, and this was 19%. So this was a 2% difference. And this was a difference of 10. So 2% of 500 is 10. 1% of 500 is 5. Of course, we should have known that, huh? Because to find a percent, you divide by 100. Okay, so we we now know that there are 85 first graders, there are 95 fourth graders, and we still know that this total is what? 500, right? Okay, the number of third grade students is 9 less than the number of fourth grade students. Well, this is cool because we know how many fourth grade students there are, right? There are 95 fourth graders. And what does the statement say? Third graders is what? Third graders is 9 less. Well, how do you find 9 less? You subtract 9, right? So in order to get third graders, we're going to do 95 take away 9. Well, I hope you don't need a calculator for that. 95 take away 10 would be 85, but we're only taking away 9, so what does that mean? It's 86. So that means there are 86 third graders. So I can go now here to third grade and I can put in 86. All right, we're getting close. We just need second grade and fifth grade. All right, the number of second grade students is 10 less than the number of fifth grade students. Oh, bummer. Why am I saying bummer? What don't I know? I don't know fifth graders, do I? And I don't know second graders. And what did they just tell me? They told me that the number of second grade students is 10 less than the number of fifth grade students. The problem is I don't know how many fifth grade students there are. Do you remember in a previous problem when we didn't know what something was, we represented it by x, right? That's what we do in algebra. Something we don't know is x. And then what do we know about second graders? Second graders is 10 less than. How do you do 10 less than x? Am I going to add 10? Divide by 10? Multiply by 10? No, I'm going to subtract 10. So what do I have here? I have 2 grades I don't know. But what do I know? I know that all of these added together is what? 500. So I can write an equation and solve it for x. And once I know what x is, I'll know what x minus 10 is. So if we take our first graders, 85, and add it to our second graders, x minus 10, and add it to our third graders, which is 86, and add it to our fourth graders, which is 95, and add it to our fifth graders, which is x. Our first plus our second plus our third plus our fourth plus our fifth equals what? 500. All right, and that's a really scary equation, but you know what? I can add this and add this and add this. And I bet some of you were wondering why I didn't do that first. I bet some of you were thinking, well, he should add those and take those away first. And we certainly can do that, right? So if I do that, I'm going to have x minus 10 plus x equals 500, right? Take away those other grades. I'm going to take away the kids in first grade, and I'm going to take away the kids in third grade, and I'm going to take away the kids in fourth grade. So I'm going to subtract all those added together, and that will give me the number of kids in what? In second and fifth, right? This right here, those are the number of kids in first and in third and in fourth. All right, so if we simplify this side, 1x plus another x makes 2x's minus 10. So 2x's minus 10 equals 500 minus 85 plus 86 plus 95. All right, so I'm going to go ahead and go to my calculator. Hopefully I can remember this. 85 plus 86 plus 95. So here we go. So I'm going to do 500. Whoops, let's go ahead and clear everything out of our calculator first. I'm going to do 500, and then I'm going to go minus, and then I'm going to put parentheses. And what were my classes again? 85 plus 86 plus 95. I sure hope I'm remembering that correctly, right? Those were 10 apart, and that was one more than that one. And that tells me that there are 234 students that are left in those 2 grades. 234 students that are left. So if I go back to my equation right here, then I have 2x minus 10 equals 234. We're almost there. So now I have a two-step equation. My goal is to find out x, so I'm going to use inverse operations. What is the opposite of subtracting 10? It is adding 10, right? 2x equals 244. And I hope you don't need a calculator to divide that, right? 244 divided by 2 is 122. 122. So what am I saying? I'm saying that that fifth grade class has 122 students. And the second grade class has how many compared to that? 10 less. So it is 112. All right, and so what does a good math student do? He or she checks his or her work. So what am I saying? I'm saying 85, 112, 86, 95, and 122. When I add those together, I better get 500. Well, I already know that 85 plus 86 plus 95 equaled 234, right? If I add those other two together, I already know that those equal 244, right? I'm sorry. No, plus the 10, excuse me. If I add these two together, let's add 112 and 122 together. It does 4 and 3 and 2. No, that's the 234. My bad. All right, so 234 is what those added up to. That's what was left. So I need to do the 85 plus the 86 plus the 95. All right, let's just do this on the calculator. I'm sorry, guys. All right, so we have the 85 plus the 86 plus the 95, right? And we're going to add that to 234, and it should equal 500. All right, so let's clear this all out. All right, so 85, that's how many were in first, right? Plus 86, that's how many were in third. Plus 95, that's how many were in fourth, right? And when we add those together, if we then add the 234, all right, that we know that were in the other two combined, we get 500. All right, guys, so second grade, what did we say that second grade was? Second grade was 112, and fifth grade was 122. So we're going to fill this in with 112, and this one is 122. All right, so I'm sorry, that was not the best job there. You can tell I'm tired. I've been doing a lot of these problems, but hopefully I didn't mess you up too bad. Those are the totals fitting the description they gave us, giving us a total of 500. Notice it says, please submit the test when you are finished. We're going to end the test, and we're going to end this video. Thanks for watching, everybody.